We are getting to the end of the unit, so this will be the last week, and we have only a few topics left, one of them being misspecification errors, which we'll be doing part of today and also Thursday maybe. But before we go there, I just want to clear two things. One is issues relating to scaling. So if you have variables and you scale them, what does that do to your regression? This is a common problem because you might not use your x and y variables the way they are. You might need to redefine them. That's the one thing. The other one is relating to what's called elasticity measure. It's a way of measuring effect. Now, so far we have been looking at what? Coefficients, right? Well, there is a slightly different way, and I want to go over that as well. So scaling. Suppose you scale your variables, x and y, and it's common to do, as I said, but if you scale and re-estimate the relationship, it's not going to change the nature of the relationship. Okay? So the numbers might change in terms of the coefficient size and so on, but the nature of the relationship, what the regression model is telling you, is not going to change. If it did, we would be in trouble, right? Because scaling is redefining units. And if you redefine units and the answer changes, then that obviously isn't something useful. So scaling doesn't do that. Here is an example. If I regress y on x1 here, estimate beta 0 and beta 1. Now, suppose I scale x by some factor s. What could s be? Well, it could be any number. Could be 10. Could be 100, could be even a 9, could be any number, okay? I scale it, let's say. So if I am talking about scaling something that's in centimeters into meters, what do? I scale it by 100, right? If I want to scale kilograms to tons, I scale that by 1,000. So S can be any number. What happens if I do that? Well, I will get a new variable which is x over s, and then I do my regression, but my new x is x over s, not the old x. I am going to get coefficient estimates. Now, the question is, what are those coefficient estimates going to be? I changed the value of x, so I would expect the slope term to change. Can't stay the same. And the way the slope coefficient is going to change is it's going to compensate for my scaling. So if I scale by a number that's above 1, my slope terms will increase to show that my x variable is now measured in bigger units than before. If I scale by something that's less than 1, that means I am inflating my x, then the slope term has to become smaller to show that the x variable is now using smaller units. So that's how it works. So what else is going to happen? Well, the slope term will change, the intercept won't change, the r-square value cannot change because we didn't change the y, right? Nothing changes. The significance levels won't change, so the model, if it was good, will stay good. If it was bad, it will stay bad. So why do you need to scale? Well, I have given you an example already. If a person who comes from a certain way of measuring things, I want to translate the units into my own system. So that's one reason. So I gave you that example already, but there can be other reasons which are purely for the way you display numbers. So you might have a mixture of things that are very small and numbers that are big. So you might have people's age, which would be what, between 15 and 64 or maybe 85, and then you have got variables like incomes, which would be in thousands, tens of thousands, or even above 100,000. And then you might have other variables which say how many times they play something, which might be just a handful of numbers. So the scales are all over the place. So that's one good example. So if you want things to be more intuitive and easier to present, numbers not being big and small and so on, you will do scaling. And that's why we need to mention this, so that you know what it does. Other reasons would be if you want changing units, which we have said. Okay, so that's scaling. What does elasticity measure? Well, as you can guess, it tells you how responsive y is to x. And it's supposed to do that in a better way. How does it do that? Well, by looking at a unitless way of measuring the effect and by focusing on proportionate changes. You look at by what percentage y changes when x changes by 1%. So it's the percentage change in y relative to the percentage change in x. Now, that's the standard definition. You can rewrite this Percentage change means change in y divided by y. That's a proportionate change. It's the same for x. If you take the ratio, you get what you see here. If you have a linear regression, what happens? We already went over this when we defined elasticity. In a log-log form, the slope term is elasticity.